All right, so tonight I'm going to talk about variance again. I think in the last video we just brushed on variance, talked more about deviation, range, kind of introed this section. And tonight I want to talk about population variance. So number one, I'm going to go back and look at some of the symbols here to make sure that we're still on the same page with that. So let's start there. There we go. So, oh boy, if my pen isn't working, let me delay just a second. If you look at that squared on the left-hand side of that equation, what that is lowercase sigma. Lowercase sigma squared represents variance. In the numerator, on the right side of the equation, you've got the deviation, in other words, distance from the actual data point from the mean of that set. We already know how to find mean from the previous lesson. So you take the distance from each data point, subtract the mean, square it, because if we don't square it, those sums come out to be 0, if you remember that from the last lesson. And then we divide, when we're working with population, we divide by the number of items in the set, which is n. In this case, so if there's 14 numbers there, we divide by 14. No surprise there. It's much like the population mean. So let me see. There we go. Okay, we're okay now. Yeah, so right here, that's what I was just talking about. That is, sorry, I'm just flipping around. That is sigma squared. And then we're looking right here. This is uppercase sigma, which represents summation. Take the summation of each of these pieces. I'm going to walk through an example tonight. And then divide by how many are in the set. Okay. Let me go off this screen. All right. Population standard deviation. The mathematical relationship between variance and standard deviation is such. The square root of the variance is the standard deviation. And if you look right here, underneath this radical sign is our variance. So if you take the square root of that variance, and remember in an equation, what you do to one side you have to do to the other. So if you take the square root of that variance, take the square root of what you're working with on the other side of the equal sign, then that's going to give you the standard deviation, which is represented by not sigma squared, but just sigma. Okay, so there's some of the classification. Now, a couple of additional items here. Mu, we're working with population. Right now we're just strictly working with population. So mu represents your population mean. The x is each individual data point, and n is how many items in the set. Okay. So if I can go forward, no, we can't go forward. We got to put here. All right. So how do we find the population variance and standard deviation? So right here it's laid out very well. I'm going to walk through this with you with a number here. And I think I did a very quick one in the last one, so I'm going to walk through a quicker one. I'm going to walk through a more detailed one here. So we find the mean of the population data set. Well, we already know how to find that. Mu equals the summation of x over n. N represents the population, numbers of items in that set. Summation of x is the summation of all the individual values. And mu, of course, represents the population mean. Next, find the deviation of each entry, x minus mu. Now remember, if you sum all those up just like this, you're going to get 0. So we're going to then take it and square it. We square each deviation. By the way, when I work through this, I'm not going to do these in such little small pieces and parts. I'm going to do it all together, but this is how it's broken out. You get the sum of squares. In other words, you take all of those x minus mu squares, the first one, the second one, the third one, all those terms, you add them up, and that's actually called the sum of squares. Talked about that a little bit in the last video. Divide by n to get the population variance, and that's it. Find the square root to get the population standard deviation. Okay, we're going to work through this. I want you to be able to work through this. My goal, remember, with these intro topics is to make sure when you're in college and you have an intro, like a statistics for business or statistics for engineering, whatever you're taking, you can work with these. You'll be familiar with these standard basic concepts in statistics. All right, let's work through this one. Finding the population standard deviation. Okay, so we're going to work through, I'm going to find the variance, and I'm just going to take the square root of it. So I'm going to go through everything at once. So a corporation hired 10 graduates. The starting salaries for each graduate are shown. Find the population variance and standard deviation of the starting salaries. Starting salaries are in thousands of dollars. I'm not going to figure that in until the very end. When we actually present it and talk about it, that's when we talk about what the numbers represent. We're going to work with them as they are here on the page. The mean here is 41.5. I think this might have been the one that we worked with range on. So we're going to walk through, and I may have actually walked through this one last time. If I did, I apologize. But we are looking for variance. So I'm going to go, the variance is the summation of x minus mu squared divided by n. Now I always, especially when I'm getting used to formulas, used to write them out. Once you write them out for all the problems that you work through, you'll feel more comfortable with it. You'll feel more comfortable working with it. You might commit it to memory short term, certainly, but we've already derived this. We've already talked about this. Now we're just using it in application. So to get used to it, start off by writing that. I certainly am not going to have enough room on this particular page to work through all the pieces. So I'm going to have some dots in the middle here to represent middle pieces. We'll start at the beginning and go to the end. Okay. So in this first one, I have 41 subtract 41.5 squared plus 38 subtract 41.5 squared plus dot 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 plus, and so I'm just going to do these first two and the last one. These right here are represented by dot dot dot. That's all the stuff in the middle. So at the end, I'm just going to have 42 subtract 41.5 squared, and I'm going to take the sum of all those terms. When I'm done, I'm just going to divide by how many are in the set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It told us there were 10 graduates. So I'm going to divide by 10 in the end. So that's what I'm going to work with here. So I'm actually going to work with this on the calculator. So let me at least get the numbers out here so I've got them here. Take me just a second, and I apologize that I didn't already have this up, but I've got 41, 38, 38, 39, 45, 47, and I'm going to walk you through the calculator portion of this as well using the cell sheets. 44, 41, 37, 42. Okay, backwards 42, 37, 41, 44, 41, 47, 45, 39, 38, and 41. Got them right. Okay, so now I'm going to go off screen for a second here. I'm going to go over to our calculator. I'm going to show you how to use the TI. Now remember, at this course, you've got to have a TI available to you. I haven't heard anything from you for needing one, so I assume that you've got a TI 84, at least access to one, probably from the school over there. You should have one. Again, if not, let me know. You can also download what I've downloaded here, which is Calc 84. Now I pay for this. It's like $6 a year just to have this emulator. You could use it with ads if you wanted to for what we're doing here. Okay. So let me start working with this calculator. So I'm going to go to Stat in the middle, and let me just show you the steps I'm going to do here. So what I'm going to do is I'm going to go to Stat right there, and then you're going to come up to a cell sheet, and we're going to put in L1 our X values, and we're going to put values in each one of these, and I'll show you how to work through it. Okay. All right. Stat. There we go. And then it's already highlighted edit, so I just hit enter. And I need to clear out what's in here, so I'm going to scroll up to L1, hit clear and enter. Scroll over to L2, clear and enter. Scroll over to L3, clear and enter. Then I'm going to go back over. I actually don't remember if I showed this last time or not. I'm going to walk through it again regardless, but I don't think I did. So I'm going to put the numbers in here. 41, enter, 38, enter, 39, 45, 47, 41, 44, 41, 37, 42. Okay. So I've got all 10 numbers in L1. And all of a sudden my calculator is locked up. $37 and 42. Oh, I know what it was. I didn't hit enter. I'm sorry. So there we go. So all of these are like such. Now I need to find the pieces and the parts. We already know that the mean was 41.5. We found that earlier. We were either found it or we were given it. I wouldn't have remembered it, but it was given in the PowerPoint that I used. And now we're going to go over here. And what I'm going to do is I'm going to put in a formula in L2 to get all my deviations down below. So my deviations, and I'm going to go ahead and square them. So my deviations are going to be, and the formula is going to look like second L1 subtract 41.5, close parentheses, and then I'm going to hit the x squared key over on the in the first column. So let me put a pause on this for a second. Bring up Desari. So here's what I did. In order to put a formula in a TI cell sheet, you have to put, well, it's not, of course it's not going to work. You have to put the formula up in the top portions if you're going to do it. So I put the formula up there in L1. It's highlighted in gray. And that's L1 subtract 41.5. Well, our deviations, if you remember, are x minus mu squared for each one of those x values. Mu was 41.5. Hence, that's why I've got that there. And instead of x, I've got L1 because what is in this first column? Well, that's all the x values. So basically, I'm telling the TI calculator, take all the x values from L1, subtract 41.5, and put it down below in L2. And that's what it's done for me. And I went ahead and squared it. So I've got everything I need. Now, I need to find the sum because if you're, I should have left that up. If you remember, we're trying to find the sum of the sum of squares in this case. And so I need to take that 0.25, 12.25, 6.25 all the way down and add those up. Now, on a small problem like this, I could write them on a sheet of paper, just plug them in and do it, no problem. I'm going to do it using the calculator. So I'm going to go to second mode, which takes me out of this. I got to put the formula in again. No problem. Second L1 subtract 41.5, close parentheses, squared. I didn't hit enter once again. So now I go second, quit, and I'm out here. The reason I want to quit is because if I start finagling with the calculator, it's going to try to put it in a separate cell in that spreadsheet. So now I'm going to go to, and this is a little slower than I wanted it to be, but now I'm going to go to second. I'm going to use the second function of the stat key, which is list. So I want to go to list. That's where sum is. And what I'm going to do is I'm going to pull out sum. It's going to have an open parenthesis. And I'm going to take the sum of column L2, which is each one of my individual entries. Okay? Each one of my sum of square entries. So back out of this. Maybe. Seems to be a little slow responsive tonight. So I go second, stat, scroll over to math, and scroll down to sum. Then I hit enter. Then I hit second 2, which puts L2 in there. Hit enter, 88.5. So 88.5 is my sum of squares for each one of those entries. And then I'm going to divide that by 10. I don't even need to put it in the calculator, just moves the decimal over, and it's 8.85. So my variance in this problem was 8.85. And if I go back to stat edit, all I did was add up those numbers, 0.25, 12.25, 6.25, 12.25, and I did that by using the calculator. And I'm going to show you one more time how I did that. So I go second mode, which takes me out of there, second quit. I'm going to hit clear. Then I go second stat, which takes me to list, scroll over to math, scroll down to sum, second L2. I should close parentheses for a good habit, but it'll still give it to you if you don't. And I get 88.5. So the sum of all those squares in the numerator was 88.5. And then I divide by how many entries there are in that set, which was 10. And my variance is 8.85. Okay? Now, let's go back here. And so, let me move my calc. My variance is 8.85. So, in order to find the standard deviation, I just take the square root of both sides. 8.85 is, it's not quite 3, so it's 2 point something. If you had to write this just real quick, you could just put 2 point something. At least you wouldn't be wrong. Let's see exactly what it is. If I look for the square root of 8.85, yeah, 2.97, almost 3. So it's 2.97, and that's your standard deviation. And that's it. Notice one thing, and I think I talked about it a little bit last time. Notice that that variance doesn't really connect with your numbers. So if you told somebody the variance was 8.85, that is a standalone number, might confuse your audience. They'll be like, well, what does that even mean? And you could break it down mathematically, but when you find the standard deviation, it takes the units of what you're working with, and they're no longer squared. They're back to their original units as what the set was, and that makes a little bit more sense. So 2.97. So we're looking at a, oops, didn't mean to do that. We're looking at a mean of 41.5, standard deviation of 2.97, almost 3. Okay, that's it. That's all we have to do for that problem. We found what we needed. So now let me go back here. And I'm not going to make this a long video tonight, but I did want to get a little bit more into this. And there is the breakdown. That is exactly what we did in the calculator. So, except that I did not do this. I went straight to this, right? Basically. So the deviations are 41 minus 41.5 squared. 38 minus 41.5 squared all the way down, and we found the sum. So, and this sum, remember, I've talked about that several times. The sum of those deviations is just 0. So we have to square them so we get something that makes some mathematical sense in what we're trying to find. When you take the squares of those and you take the sum all the way down, the sum of squares is 88.5. We found that already. No problem. We found it in the calculator. Whoops, doing the same thing, by the way. And you go across here. Yeah. I think I just left it. I don't think I rounded it 8.9. It's okay. I didn't give any specifics on that. So rounded is 8.9. The standard deviation is approximately 3. Notice that is not, notice mathematically, that is a double tilde, which means it's like we got 2.97. And remember I said it was 2 point something, very close to 3. And it's, for all practical purposes, approximately 3. And that's what that double tilde means. It's not equal to 3, but it's approximately 3 for what we're doing here in this problem. If you are a pharmacist or you're trying to fire a rocket to the moon, you certainly don't want to use tilde. You want to be exact. But in the case of this example, I think we'll be okay. All right. Sorry. All right, sample variance. Let's take a look at sample variance, sample standard deviation. The only there's several differences here. So the main differences are just the way it's laid out. If you remember, as you're learning this, our population variance was sigma squared equals the summation of x minus mu squared divided by n. And now we're looking at something that's equivalent to, but slightly different. We have to take some things into account when we're working with a sample because we know some things. We want to eliminate some bias. So in order to eliminate bias, in simple terms, in order to eliminate bias, that's why we're working with n minus 1. That's it. The two differences in this there's not going to be a huge difference in those numbers, but there is a difference. So let me erase this off. So we are x minus x bar, and x bar is the sample mean. So we're still taking each individual number in that set, subtracting out the mean, except in this case we're taking the mean of whatever sample we're working with. We still square it, and instead of dividing by n, we divide by n minus 1. Excuse me. Now finding sample standard deviation is the exact same. That mathematical relationship is the exact same. You take the square root of both sides. So your standard deviation is just that. So whatever you find for here, whatever that number is, you take that number, find the square root of it. That's it. All right, what I'm going to do, I know that's just one problem for tonight. I'm going to upload this video. I took a little bit of time, worked through the calculator some. Certainly have this as reference. I'm going to upload some assignment from this section, and I've also uploaded a quiz for you to work on. And while you're working on the quiz, you can look at the note set. I want you to be familiar with those vocabulary. So you can work on that. I want you to know those vocabulary. I want you to be able to work through some of these problems. I'll assign those, and then I'll try to upload something in the next day or two to get ready for what we're going to have here pretty soon, which is going to be a test on measures of center, measures of variation. And I'll also have one where I'll go through and only work through problems. And I'll make sure instead of having words on here from a PowerPoint, I have a blank screen, and I'll just work the problems through. Pretty basic. So, all right, that's all I've got for tonight. So I'm going to upload this video. There is a quiz on... There's a quiz on vocabulary. Sorry, I got sidetracked because once again I did not change that from measures of center to measures of variance on the scroll and ticker. But I think we know what we're working with by what I'm working with on the screen. So that's all I've got for tonight. I'll upload this tonight, and I will put an assignment in there from the online book, the PDF version that I have uploaded. All right, thanks.